Good morning, guys. Let's have another lesson which is all about parallel LC circuits. So this is the diagram or schematic diagram of a parallel LC circuit. As you can see, the terminal, the upper terminal of the inductor and capacitor are all directly connected to the source voltage. And the lower terminal of both inductor and capacitor are directly connected to the source voltage. Okay? Then we are going to get the value of the inductive reactance and the capacitive reactance. Okay? With the given value of frequency and the source voltage. Okay? So, let's compute. Okay, compute the capacitive reactance and the inductive reactance with the given parallel LC circuits. There we have here the value of inductor. The inductance is 100 millihenry. Capacitor, the capacitance value is 10 microfarad with a source voltage of 10 volts and a frequency of 160 Hertz. So to compute the XC and XL, we will use the formula. So formula of XC, same with the LC or series LC circuits. So XC is equal to 1 divided by open parenthesis 2 times pi times F times C close parenthesis. Then the formula of XL is equal to 2 times pi times F times L. Solution. So let's substitute the value of pi, F, and C. So your XC now, or capacitive reactance, is equal to 1 divided by, open parenthesis, 2 times 3.14, the value of your pi, times 160, which is the value, this is 160 Hertz, the value of your frequency, times 0.00001 farad, which is the value of your capacitor here, the capacitance value. Now, you can see it is 10 microfarad. Do not write 10 here because the answer will be wrong. So you have to change microfarad to farad. How? This is micro, which means million. So you have to divide 10 microfarad by 1 million, and which is equal to 0.00001 farad. Then multiply all of this value here, and then you have to divide the 1 by the product of this. So XC now will be equal to 99.52 ohms. Okay, next we are going to solve for XL, inductive reactance, which is equal to 2 times pi times F times L. So substitute the value of pi, F, and L. So your XL now, inductive reactance, is equal to 2 times 3.14, which is the value of your pi, times 160 Hertz, which is the value of your F, times 0.1 Henry, which is the value of your inductor. Now, as you can see here, your inductor, the inductance value is 100 millihenry. So do not write 100 milli here, 100 millihenry, because your answer will be wrong. So all you have to do is you have to change millihenry to Henry. Okay? So how? Now milli means 1000. So you have to divide 100 milli by 1000, and which is equal to 0.1 Henry. So what is the product of this? So your XL now will be equal to 100.48 ohms. Okay? So next, okay, let's use the Ohm's law formula. So compute the total impedance the symbol of impedance is Z. Total current, the symbol is IT. Current of capacitor, the symbol is IC. And the current of inductor, the symbol is IL. So, with a given circuit, same circuit, okay, same value of the inductor and capacitor. So, formula, this is the formula of impedance. So, your Z is equal to, open parenthesis, XL times XC, close parenthesis, divided by the square root of, open parenthesis, XL minus XC, close parenthesis, squared. Okay. Then, the formula of IT, which is equal to the source voltage divided by the Z. And then, IC, or capacitor current, is equal to source voltage divided by XC. Then, IL, or inductor current, is equal to source voltage divided by XL. Okay, solution. So this is the value of your XC, 99.52 ohms. And then the value of XL is 100.48 ohms. So let's solve the impedance. Okay, so let's substitute the value of XL, which is this one, the value of XC, which is this, 99.52. So your Z now will be equal to, okay, Z is equal to, open parenthesis, 100.48 times 99.52, close parenthesis, divided by the square root of, open parenthesis, 100.48 minus 99.52, close parenthesis, squared. So, your Z now is equal to 10,416.4. Okay? So, once you have this value of your impedance, you can now solve for the total current. So, total current is equal to Vs divided by Z. Substitute the value of Vs and Z. Vs is 10. Your Z is 10,416.4. Okay? So, your total current now is equal to 0.00096 ampere. Okay? And then, once you have the total current, you can also solve for the capacitor current and also inductor current. So, first, we are going to solve for IC is equal to Vs divided by XC. So, substitute the value of Vs and XC. So, 10, or IC is equal to 10 divided by 99.52. So, your IC is equal to 0.1 ampere. And then, you can solve for inductor current, which is equal to Vs divided by XL. Substitute the value of Vs and XL. So, your IL now is equal to 10. By the way, this is divide. Okay. This is divide. Okay. So, 10 divided by, this is divide, guys. Okay. This is divide. So, 10 divided by 100.48. So, your IL will be equal to 0.099 ampere. Okay. So, this is divide, guys. Okay. This is divide. Okay. So, 10 divided by 100.48 is equal to 0.099 ampere. Then, is this correct? The IC and IL. How will you know that this one is correct? And how will you know that this one is also correct? So, let's solve for the total current. Let's use another formula to solve for total current. So, this is now the formula. Okay, so this is the formula to solve for total current, which is equal to IT is equal to the square root of open parenthesis IC minus IL, close parenthesis, squared. Okay, so this is the formula, guys, on how to solve for the total current. Okay, so we have here, substitute the value of IC, which is 0.01, this one, and substitute the value of IL, which is 0.099, then close parenthesis squared. Okay, so your total current, guys, is equal to 0.001 ampere. The computer now becomes slower. So your IT is equal to 0.001, and which is equal here. If you round off this one, this will become 0.001 ampere. So that's all, guys, for the parallel LC circuit. Okay, and see you next C-High online training. Thank you.